a weather forecast and predicting the weather from any time from a day out to a week in advance is one of the world's greatest challenges for many reasons. The first and main reason is that the atmosphere is a chaotic environment with so many different variables that influence the day-to-day weather conditions at any one site across the globe. At the National Weather Service, we rely on numerous sources of data to help us do that forecast. Some of the most important sources of data come from observations, and those observations can be from the satellites way up in space, surface observations that measure temperature, dew point, pressure, rainfall, snowfall, all those types of things. Weather balloons that go up and measure the vertical profiles of all those important ingredients. We get measurements from aircraft observations, from human observers on the ground, many different sources of observations, millions a day. All these observations have to go somewhere because we can't, as humans, we can't process all that information and make sense out of it. So we rely on supercomputers that ingest all these observations, and then it's just a matter of mathematics. I mean, really, it's very complex mathematical equations that are set to how the atmosphere actually works. So the observations are fed into these mathematical equations that are forecast equations, and then the supercomputers generate a forecast from an hour in advance all the way out to 7 days and even beyond, much longer forecasts. We do seasonal forecasts as well. But without those supercomputers, it is almost impossible to do an accurate forecast more than just a few days out. Now, given how much these supercomputers have improved over the last decades, we can now do a fairly accurate forecast out to 7 days in the future. Forecasting in Colorado is an added challenge relative to the flatter lands of the central and southern plains of the United States. The main reason? Our complex terrain, which covers at least half of the state, all of western Colorado. The reason it's such a challenge to forecast in Colorado, to help you illustrate that, think about the atmosphere as a stream of water flowing from west to east, because that's usually the direction that the winds far off the ground are traveling, west to east. That's almost all weather systems travel west to east as well. So here's Colorado in the middle of this stream. Obviously with the mountains, picture them as giant boulders placed in the middle of the stream, and that water has to flow right over the top of it. It can't flow around it because it's such a big barrier of a rock. So it's going over it and it's causing little ripples and waves downstream, and the whole process just becomes very turbulent in terms of how the water flows over the mountains. Oftentimes you can get curling waves just downstream of large rocks in the stream, or sometimes with, let's say it's a much smaller rock, as it flows around that rock, you get little eddies, which are little swirls or whirlpools that form downwind of these obstacles in the flow. Well, in Colorado, that's exactly how the atmosphere behaves, just like water flowing in a stream. So we get lots of chaotic and turbulent motions on top of the mountains and then downstream of the mountains, which is to the east of the mountains, where most of us live in the Denver metro I-25 urban corridor. Numerical weather prediction has a challenge with forecasting and resolving all these little features that occur over and just to the east of the mountains. So a lot of the times it's helpful and almost it is necessary to have a human forecaster help interpret the results of the model, because the models just don't have a good sense of what the atmosphere is going to do as it flows over the mountains. Forecasters that have grown up here, that have made forecasts in Colorado for decades, have that experience. They understand that when flow of a certain direction occurs over the Rocky Mountains, they kind of understand what's going to happen across the plains of Colorado and how precipitation patterns are influenced by which direction the wind is blowing and those types of things. So with Colorado's terrain, precipitation patterns, so things like heavy rainfall, heavy snowfall, blizzards, a lot of where those occur depends on where you are relative to the terrain of the Rocky Mountains. And the two terms that I'll be referring to in terms of where those precipitation patterns occur is upslope and downslope. And they kind of mean exactly how they sound. Upslope flow is where the winds are blowing up the slope. So you can imagine in the atmosphere, when rising motion occurs, that's when flow goes up the slope. The atmosphere cools, condenses, precipitation forms. So whenever you have flow going up the slope along the terrain, you can get precipitation there. So our biggest snows, at least in the Front Range urban corridor, occur when we get east or northeast flow running into the Rocky Mountains, rising and condensing and forming precipitation. On the other hand, the ski areas on the western slope, that's on the west side of the Continental Divide, they benefit from westerly flow because that's coming in and then going up the slope from west to east. Almost all winter, the flow goes west to east generally. So just put a little moisture in that flow and you're going to get some good snow. That's the very reason why most of the ski areas are located either on the very tops of the ridges on the Continental Divide or just on the west slope there. That's where all winter long you get upslope flow there. Conversely, downslope flow eliminates precipitation, or in essence doesn't even allow it to form, because as air starts high and then descends, it dries out, and most of the time it even warms significantly as well. So in areas where downslope flow occurs, precipitation is very hard to come by. You've heard of the term rain shadow. The reason there's a rain shadow across the I-25 corridor is because of westerly flow going over the mountains and then descending the east slopes into the I-25 corridor across Colorado. So those areas are typically much drier, and anytime we get westerly flow, it's tough to get snow or rain across those areas. So upslope and downslope, figuring those two things out takes a lot of forecaster experience, decades of learning. You know, a north-northeast flow means upslope's going to occur in this part of Colorado. A west flow means it's going to occur in this part of Colorado. Models can help, but experience is critical to understanding where the heaviest precipitation might occur in those areas. A local example of why it's so challenging, or why perception of a bad forecast may be out there, can be found in the Colorado floods of September 2013. Remember that event when it rained almost 20 inches across parts of Boulder and in the foothills west of Denver, Boulder, and Fort Collins. It was a high-end flood event. Well, the rainfall patterns were such that some places, like Boulder, got between 18 and 19 inches over the 5-day period. You just go 10 miles east or 15 miles into downtown Denver when only just a few inches of rain fell over the same period. And then southeast of there, across Aurora, they also got quite a bit of rain that caused significant flooding. Between the humans and the numerical weather prediction models that help us predict the weather, none of those can pinpoint rainfall within that degree of accuracy. We have a hard time even saying within a 25-mile radius, hey, the heaviest rain is going to fall here, therefore expect the worst flooding conditions to occur. The best we can do is once the storms form, and if they're sitting over the same area, then in the next couple hours, 2 to 3 hours, we can say, yes, flash flooding is likely there, but hours to days in advance before the storms form, that's an impossibility with the current predictive capabilities that we have with the computer models and with the forecasters that interpret those models and rely on their experience in those local areas. I'd be lying if I said that I don't absolutely love forecasting. And forecasters across the National Weather Service, we all feel the same way. We love the challenge day to day that the atmosphere provides, being how chaotic it is. Uh, we still see things we haven't seen before almost on a daily basis when we do our forecast process. So we take great pride in relying on those years of experience, learning the local conditions, wherever we're doing the forecast, and translating that information so that the public, our partners, have the right information at their fingertips to make those critical decisions that they make every single day when it comes to the weather.